Good morning, class. Wonderful. Good morning.
Good morning, senior.
Good morning, sir.
So how are you guys doing?
You're doing well, bro.
Oh, we thank God, we thank God. And how was the weekend?
It was quite stressful, but
But once we started schooling, you should expect that thing. So I think now you should psych yourself and deal with it, okay? Please make sure you deal with the stress. Don't let the stress deal with you. You have to deal with it, please. Okay?
Okay.
Are you guys with me?
yes, sir.
Yeah.
Yeah, please deal with it. Then try to manage it. Okay. Try to manage. Don't stress yourself so much. Okay. Don't forget that degree is awarded. It's awarded. You don't earn it. It's awarded. So just so please just manage it. Okay. Just manage it and then do your best. But don't stress yourself so much. Okay. Especially this period. Because if you're not careful and then you stress yourself so much, probably getting to the end of the semester, we are praying to God that that thing happen. But as long as you are human being, you can't cheat nature. Do you get it? So please manage the stress level. Okay.
Thank you, sir.
Okay. So I'm far behind time. So today I'm going to talk about the sampling techniques. Okay. That's what we are going to talk about. And I sent a video and a lecture note for next week's class, and that will be on sample size calculations. Okay. So please, after the class, try your best to watch the video and practice so that when I come, it will be just a repetition. Okay.
Okay, sir.
Okay. So please, I'm starting the class right now. Let me share with you. Where is this? Where is this? Where is this? Okay. So previous meetings we learned what sample is and what population is. I think I can see a hand up. Menu, talk to me.
Yes, please, good morning.
Good morning, Menu.
I beg, this is a quick one. Last time you gave us some quick assignment to do, but we had no means to submit it. I think someone has even written it at the comment section, but I don't know whether you have chance on it. So I was just asking whether you give us a means today. Just a quick one, sorry.
Yeah, in fact, that was a somehow a try thing that I expected you to try your hand on. Yeah, the class rep called me that some of you are not having access to the Google Drive, but some of you were able to submit it. I'm sure you know the email that's is assigned to that Google Drive is the institutional email. Is from the school, and so I'm sure probably because the rate at which people are going in there, the system probably blocked some of you guys. And then he suggested that, and then he's going to add me to your WhatsApp platform so that at least you can share with me there. But I told him that about last 2 semesters or 3 semesters, someone tried to hack my number. But so I've decided not to join student platforms again, student WhatsApp again. So I told him that he should inform the class that the most important thing is your ability to draw the graphs here and there. So if you're able to draw it, that should be okay. As I said, I'm not going to examine you on that, but I want you to have a feel of it. more or less a practical aspect of it, not necessarily the manual or the theoretical, the theories behind these and these manual computations here and there. I want you to have a feel of using the software to do all these computations. Okay, and so that's the reason why I shared that thing with you. I hope that is clear. And so please,
Yeah, sure.
please forgive me if we were not able to submit it, but some of you were able to submit. And then, as I said, please just assess yourself and see if you're able to draw it. That is the most important. Okay. And so I'll talk to the class rep if we will get another means where probably we can share such thing as time goes on. I hope so. Sorry about that. Forgive me for that thing. I hope I'm forgiving.
All right, sure, sir. Thank you.
Yes, sir.
Okay, thank you very much. So don't worry so much. Okay. So what I intend also doing is when I start with the inferential statistics, that's the hypothesis testing. What I'll do is each test that I work or so each topic or each statistical tool or statistical method that I work or teach, I'll make sure I get you a video on YouTube how to use Excel to do those things. Okay. I know Excel can work with can compute t-test, can compute correlation, and also can compute chi-square test. So that's what I'll do. I'll always share a link on YouTube where you can use Excel to do those things. So that at your free time, you practice that one too. Even though I said I'm not going to examine you on that one. Because I will be very, very happy that you were able to do that one. Because in fact, in this era, you should be able to use the software to do those basic things. Okay. So I'll always share a link in the video with you. Even if it's not part of the video, I'll make sure I'll go search online, get the video, and share with you. So if I don't share with you, remind me, and I get it for you guys. Okay. And don't forget that one, I'm not going to examine you on it. So the one that I'm going to examine you on is the manual calculations. So you have to pay attention to that one. Don't go and watch only the video, the practical thing, because here you are not going to do much. You are not even going to do any practical thing. The practical thing will be on the your personal thing when you are doing your project work. Okay. But in the end of semester exam, you come and sit and then you do your computations. Anyway, that's just by the way. I think we can start today's class. Please, my sisters and brothers, can I start today's class?
Yes.
Vero? Okay,
Okay.
good. So we can start, right?
Yes, please.
Okay. Okay, so now as I said last week, we learned something about population and sample. And then we learned that it's from the population that we get a sample. So today, what we are going to learn is the methods that we can use to get the sample. Okay. So when we say sampling is different from sample. Okay, sampling is different from sample. Okay, so whenever we say sample, is the processes that we go through or the processes that we use to get our sample. The processes that we use to get our sample. So that is the reason why I've put this sketch there in the notes. So when we have your population, then you go through some processes or some techniques. Okay, and that's what we refer to as sampling. And when you go through that, then you can now arrive at your sample. So the processes that we use to get our sample, the processes that we go through to get the sample is what we refer to as sampling techniques. And these processes, we can group them into two. We have what we call the probability sampling and the non-probability sampling. Okay, so for probability sampling, what we mean is it is based on randomness. It is based on randomness. That means that it happened by chance. Okay, it happened by chance. Nobody or no one influences the something to be part of the population, or no one can influence the selection of individuals to be part of the population. It happened by chance, random. And then the non-random is not based on randomness. That one is not based on randomness. That means that it does not happen by chance. Okay, that means that it's influenced by something before that item or that person or that individual can be part of the population. Sorry, of the sample. Okay, so the sketch that you are seeing right now, the one on the left-hand side represents probability sampling, and the one on the right-hand side represents the non-probability sampling technique. And then you can see that the one on the left-hand side reflects the population very well as compared to that of the one on the right-hand side. Because you can see that the one on the right-hand side is selecting only the vertical ones and the horizontal ones. Okay, it's selecting only the vertical and horizontal ones. So if it's selecting only the vertical and horizontal ones, then you can see that it's somehow biased. Do you get it? It's somehow biased. So you can get probably this one, you can get only males, you can get only females. But if you look at the one on the left-hand side, it's a true reflection. At least you get information from every part of the population. And that is the reason why in most research, they use probability sampling. But it doesn't mean that you cannot use the non-probability sampling. Okay. At times, there are certain research that you can't even apply the probability sampling. You have to follow on the non-probability sampling. Okay. So we are going to learn some of the probability sampling techniques. Okay. So for the probability sampling technique for this class, we are going to learn about the simple random, stratified, cluster, and multi-stage sampling. We are going to learn the simple random, stratified, cluster, systematic, and multi-stage sampling. Okay. So I'm going to talk about the simple random. After that, I'll pause and ask if there's any question, or whilst I teach. Okay, let me do it this way. Whilst I'm teaching, if you have any question, please let me know. Okay, please. Whilst I'm teaching, please let me know if you have any question. So for the simple random sampling, what we mean is every individual or every person has equal chance. They have equal chance. They all get equal chance to be part of the sample. Okay? They all have equal chance to be part of the sample. They all have equal chance with simple random sampling. And so for the simple random sampling, for example, if I want to sample from the class right now, let's say I want to do a research concerning nursing A students. Okay? There's A students. So, I wish we are going. Please give me something. I need to. Okay, so let's continue. So let's say I want to do a research on let's say malaria among the nursing A class. Okay, so what I can do is, if I'm going to use simple random sample. For example, if I want to select, let's say Veronica, the chances of the chances of Veronica to be part of the sample is going to be 1 out of the lot. And this lot, let's say this class, right now we have 532. Okay, so that means that the chances of Vero to be part will be 1 over 532. Okay, and so that of, let's say, another person, let's say Gordon or whatever, his to will be 1 over that, 1 over that. So you see that everybody has equal chance. Every person, they have equal chance to be part of the sample. And that's what we refer to as the simple random sample. Okay. And that's what we refer to as the simple random sample. So, and this simple random sampling, you can do it by what we call the lottery method. What we call the lottery method. So, for the lottery method, what you can do is, let's say, the same class, what I can do is I have to number every person. I'll assign a number to every person. Let's say 1, 2, 3, 4, 5, so on and so forth. So I get to the last person, 500 and let's say 40. So if I finish, then I can fold these numbers, and randomly I pick a number. So the number that I pick, let's say randomly I pick a number 24. Okay, I pick a number 24. So that means that the person with that number 24 is going to be part of the sample. Okay. If I pick another number, let's say 1, that means that that person with that number will be part of the sample. So you see that this one is random. It's random. Nobody have any prior information that you are going to choose this number, you are going to do that, you are going to do that. And that is what we refer to as the simple random sample. So let me pause and take questions. Let me pause for some few minutes and take questions. So if you have any question, you can raise your hand. Okay, my brothers and sisters, sorry about that. I'm sorry. Okay, there was an emergency I have to attend. Please, sorry. Okay, so I didn't see any hand up, even though I used this opportunity for you to ask questions. Right? You didn't talk. So let's continue. If there's no question, I hope I can continue, please. Vero, can we continue?
Yes, sir. Please do continue.
Okay. So there's a sketch here that is illustrating the Simple random sample. So if you look at this one, the population size is 15. That means you have 15 individuals in the population, and randomly we are selecting it. Okay, so you just assign numbers. So randomly, then you can just pick some. And you can also go by what we call the random numbers generator. That one, the computer will generate random numbers. And so then you can use that random number and to identify the individual that you are going to select. That's what we call simple random sample. Okay. The next is the stratified sample. Stratified sample. So for stratified sample, it is used for a population where you have different characteristics or a lot of variation in the population, and that is what we term as heterogeneous. Heterogeneous. And so what you will have to do is, because they have different characteristics, you, the researcher, you have to group them into common groups. Okay, so you have to group them into common groups. And so you can see that after grouping them, you, the researcher, you will see that in the groups, they will be having common characteristics in the groups. But between the groups, they will be having different characteristics. Okay. And so, for example, let's say I want to sample from Garden City University for my research. Okay, let's say it's about, let's say, let's say it's about hypertension in Garden City University. So this time around, I want to do it in Garden City University. If I go by simple random sampling, it is possible that I'll end up selecting only probably lecturers. It's possible. I may end up selecting only lecturers. And so you see that that will not be a true reflection of the Garden City University. Because Garden City University, we have the teaching staff and non-teaching staff. We even have the students. Even the students, we have departments. We have nursing and midwifery, we have environmental, we have computer science here, and so on and so forth. We even have master students here, and so on and so forth. So you, the researcher, you have to know that this scenario or this problem or this research calls for stratified sample. Nobody will come and tell you to use it. Okay. So for this one, I can go by my stratified sample. And so you, the researcher, always you will have to determine how you form your groups. So I can say that, oh, now I'm going to use the departments as the groups. So I have the nursing and midwifery or the programs. I'll have the nurses in one groups. I'll have the midwives one groups, the computer science one group, lecturers. I'll put them in one group. I'll put the non-teaching staff, that the administrators also one group, so on and so forth. Then I can now go within each group, then do my selection. Do you get the point? I can now go within each group. And do my selection. And so you can see that that one will be a true reflection of the population than the just the simple random sample. Okay. And that is the reason why it's always advisable to use stratified sampling when you perceive that there are a lot of different variations in there. Another example is, let's say you want to do a research in, let's say, Ashanti region, okay? And it is perceived that Ashanti region, we have a lot of ethnic groups, okay? So let's assume that you want to group the individuals, you have a group for, let's say, Akans, the other ethnic groups, so on and so forth. And so within each group that you create, you can now go inside and get your sample. So it depends. For example, another example is, let's say you want to group schools. You have schools. You can group them into, let's say, all these, one, that, so on and so forth. Okay. So it depends on you, the researcher. Okay. It depends on you, the researcher. Okay. I can see a hand up. Ajay Kwabena Emmanuel. Please ask your question. Ajay, you can mute yourself. Okay.
Yeah.
You should be able to mute yourself.
We are enjoying your lectures, but just that the volume is too low.
Oh, yeah, so.
Yes, please.
Oh, okay. Sorry about that. But is it okay now? Is it
So,
okay?
yes, yes.
Okay.
Thank you.
So you want me to shout? Hey, okay. Then you get ready to buy me vitamin C, okay? So if I get sore throat, you help me buy vitamin C for me, okay? Okay, so that's just that. By the way, let's continue. Let's continue. So this is an example. So you see that from this sketch. So Kwamina, please lower your hand. Okay. So if you look at this, you can see that we are grouping all those with red in one group, all those in blue one group, and all those in yellow one group. So we've been able to form each group, and in the group we are selecting, and this is what we refer to as structure. Each group is referred to as structure. Each group, and if I put all these groups together, that's what we refer to as stratified, or I mean strata. Strata. Okay. So that is what we mean by stratified sum. Stratified sum. Okay. You have a hand up? You have a hand up? You have a hand up? There's no hand up. Okay. So let's continue. Let's continue. Okay, there's a hand here. Charles. Charles, talk to me. Please hurry up. We are fine behind time. I need to finish this today. Charles, please talk to me. Charles, you can unmute yourself and talk. Oh,
Okay, sir.
okay.
I was having a problem on muting myself. That's why.
Okay.
So, from the stratified sampling, you made mention of that it's used when you have different characteristics, and you said it's also called heterogeneous. But in the slides, you stated
No,
homogeneous there. So I wanted you to clarify us on both.
I didn't say it's called heterogeneous. I said that when it is perceived that we have heterogeneous population.
Population.
So
Okay.
yeah, so when you hear heterogeneous, these are some technical words that we use. So when you say heterogeneous, what it means is there are a lot of variations in there.
Variations in there.
There are a lot of
And then
variations. And when we say homo, they are having common characteristics.
Common characteristics. Okay. So from the picture you just presented, I wanted to ask that those stratums that you showed us, you see some of them were wearing red shirt, others were wearing blue shirt. For instance, let's take it that you cited an example like going to Ashanti region, there are a whole lot of ethnic groups. Maybe Akans are there, Dagombes are there. For instance, when you pick these stratums, and out of one clan, for instance, let's take that Akan, and you pick people from it, can you state that one is homogeneous?
Yeah. So
and then when you try mixing them, it's heterogeneous.
So in the group, in the group, you see that in the group they are homogeneous. You see that in the group they are having common characteristics.
Common characteristics.
All red. But between the group, it is heterogeneous.
Heterogeneous. Okay. Thank you. Yes, please. Thank you.
Okay, that's fine. I think we can continue. Please make sure you mute yourself, please. Okay, so let's go to what we call the cluster sample. Cluster. So the cluster sample somehow they are not the same as students always ask me that is the cluster the same as the stratified. No, they are not the same. But they exhibit some similarities, but they are not the same. Okay, so for cluster sampling, it is used for a wide geographical area. Then when it is perceived that this time around the population have homogeneous characteristics, they are having some homogeneous characteristics. That means that they are having some common characteristics. Then you can group them to subgroups, and then you can select a cluster to represent that group, or you can select a cluster, and then you go within that cluster to select again. Let me go over. So for cluster sample, it is used for a population where it is perceived that they have common characteristics. Okay, they have common characteristics. That means they are homogeneous. And so you can group them into clusters, and then you can select a cluster to represent them, or you go further. That's what we are going to learn. So, for example, let's say I want to conduct a research, let's say in Ghana, and so it is perceived that we are all Ghanaians. So we are all having common characteristics. We are all Ghanaians. So what I can do is, as a researcher, I can group the country into clusters, right? And these clusters, I can use the regions as my clusters. So Ashanti region will be one cluster, Upper East, Upper West, Northern, Bono, Ahafo, Accra, so on and so forth, Greater Accra, so on and so forth. All these are going to be the clusters. And then I can now apply my simple random. Randomly, I select a cluster to represent the whole Ghana. So if let's assume that randomly I selected, let's say I selected Ashanti region to represent the whole Ghana, then that means that Ashanti has been selected. So Ashanti region is the cluster representing the whole Ghana. Okay, so if I randomly select, let's say 4 or 5 clusters, and these clusters are going to represent the whole Ghana. And that is what we refer to as single stage cluster sample. The single stage cluster sample. Please, hold on. Single stage cluster sample. Single stage cluster sample. So if, let me put it there. So if you move further, let's say you don't end at a single stage after you group them into clusters, you don't end there. You move further to select again. Okay, then that means that you are doing what we call the two-stage cluster sample. Two-stage cluster sample. So for the single stage, if you randomly select a cluster, for example, let's assume that this is region 1, region 2, region 3, region 4, region 5. Okay. So if I randomly select region 1, that's cluster 1. If it's single stage, every person in there is part of the sample. Every person in that cluster, they are part of the sample. And that's what we refer to as the single stage. Okay. On the other hand, if I want to move further and go by what we call the two-stage cluster sample, the two-stage cluster sample. For the two-stage cluster sample, what it means is after you are done with a single stage, you don't end there. You have to move further. That's you randomly go in the cluster again. So that means that this is first, that the single stage, then I come in the cluster, right? I come in the cluster, and in the cluster, I do another selection in the cluster. So you see that this time around, I'm selecting again. Do you get it? So in the cluster 2, I'll do another selection, and then they are going to be part of the sample. So you build on the single stage to get the two-stage cluster sample. Okay. So let me give another example, which is a different context, but I want you to get a concept. Let's assume that I'm doing a research in your family, okay? In your family. And then in your family, let's assume this is the family, okay? This is the family. Cluster 1 is your family. You have your mother, your father, yourself, and other 3 siblings, okay? Other 3 siblings. So if I'm going by single stage, then it means that if I select your family, every person in the family will be part of the sample. If it is a single stage, every person in the family part of the sample. If it's single stage, every person in the family be part of the sample. But if it is two stage, then it means that when I select your family, I don't end there. I come, I knock. You say come in. So I come inside your family and I do another selection. So let's assume that in the family, I selected your mom, your dad, and yourself. So the three of you are now going to be part of the sample. And that's what we refer to as the two-stage cluster sampling. Two-stage cluster sampling. I hope that's clear. Okay.
Okay.
Please, this one is a bit confusing. The one that we are going to talk about system. Yeah. Is there any question?
Yes,
Please, if you have a
please.
question, talk to me.
Yeah. Please, about the two-stage sampling.
Please, can you
Please,
speak
I
a
didn't
bit?
get it. So I was saying that the two-stage sampling, I didn't get it well.
Oh, you didn't get a two-stage sampling, cluster sampling.
Yes, please. Yes, please.
Okay, so that's why I was using your family as an example. Let's assume that I want to sample, okay, for families in, let's say, your locality. And then I'm going by the two-stage cluster sampling. So what I will do is I'll randomly select a cluster. So let's assume that randomly I selected your family. And so if it is single stage, it means that all the family members are going to be part of the sample. Is that okay?
Yes, sir.
That is single stage. Okay. So for two-stage cluster sampling, it does not end at a single stage. So what I will do is I will now come in the family that I selected, that's the cluster, and then in the family, I randomly select in again. Okay. So in your family, now that I've selected your family, I now come in the family and I do another selection in there. And so let's assume that in that family, I selected you, your mom, and the two of you are now going to be part of the sample. So you see that I did not end at just selecting your family. After I selected the family, I now came, move inside and then select again. I hope that is clear.
Yes, sir. Please, sir, please, your voice is quite low. Can you?
My voice, I don't know
The
what I
volume,
can do to you.
your volume.
Can you hear me? Is it better?
Yes, sir. Yes, sir. Yes, sir. Yes.
Okay. Okay,
Thank you,
I
sir.
hear.
Thank
Okay.
you.
Okay. Okay. So please, so if the voice is low, please feel free and alert me. Okay.
Okay, sir.
Okay. So now let's move on to what we call the systematic sampling. This is not systematic classroom. I need to change it. Okay, so it's systematic sampling. Systematic. So for the systematic sampling, what you do it, you always and always select every kth item. K. Every kth item. You always select every kth item. K. And this is the K. This is letter K. 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 This K stands for a position. So it's just a position. The K stands for just a position. It doesn't necessarily mean that it's something abstract. So someone can choose to call it A, B, C, D. It depends on you. So this K stands for just a position. And this position, you, the researcher, you will need to, calculate your K. Okay, you need to compute your K. So someone may ask, how do you get this K? So the moment you are able to get the K, you are good to go. Then you can now go and select every kth item, the position that you've computed. So you need to always and always calculate your K. And this K is given as the population size divided by the sample size. The K is always
the population size divided by the sample size. So the moment you are able to calculate your K, you are good to go. You get your population size, and then you have your sample size. You can now go and compute your K. Okay, so now let's take one example, and then so for this time, let's assume that we have a population of 20. Okay, and then we want to sample 5 out of the 20. Okay, we want to sample 5 out of the 20. So what can we do? We have to calculate our K. And so the K is going to be 20 divided by what? 5. Again, the K is going to be 20 divided by 5. So if 20 divided by 5 will give us what? 4. So now it means that we are now going to select every fourth element. Every fourth element. Every fourth element. So it means that every fourth item or every fourth individual or every fourth person is the one that we are going to select. So if I have some folders in a shelf, I can go by the simple, I can go by this systematic sample. Okay. If I have some, let's say, houses in a line form, I can also go by systematic sampling. So now let's come back. So now, once we've been able to calculate our K, that we have the K to be 4. So we are selecting every fourth element. Every fourth. So this every fourth element, what I am showing to you guys here is this N1 means that I randomly selected the third person out of the 20. So do not think that it is something weird. Okay? Do not think that it's something weird. So what you can do is this N1 stands for the first selection that I did, N2 the second selection, N3 the third selection, and so on and so forth. So if I select the first person to be 3, don't forget we are selecting every fourth element. So if I select 3, the next item that I will select will be what? 4. Okay, so that is 3 plus 4. So 3 plus 4 give us what? 7. That is why I have N2 to be 7. Okay, so let me illustrate whatever I'm doing here, and I'll come back to this slide. Okay, someone may think that is so weird. This thing is simple. So let's look at this sketch. Don't forget that we have 20 individuals in the population. So it means that the 20th person did not appear here. So we should have 20. So randomly, we have our K to be equal to what? 4. Our K is now 4. Please, my sisters and brothers, keep in mind, for the systematic sampling, your starting point, you can start from 1 to K. And that is what I advise students to start from, 1 to K. So it means that this one, we can start from 1 up to 4. Okay. So our starting point should be 1 up to 4. So from 1, 2, 3, 4, we can start from any point. But you don't just go and pick, let's say, the first person because the first person is Veronica. So I just go and pick Veronica because she's the class rep. No. You don't do that. You must go by the simple random. So statisticians are saying that simple random sampling is the mother of all probability sampling techniques. Because at any point in time, we are applying simple random sampling based on the selections. So here we have 1, 2, 3, 4. 1, 2, 3, 4. Okay. So let's assume randomly, I selected what? Number 3. So I randomly selected number 3. So we are selecting every fourth item. So now we are moving in 4 steps. So 1, 2, 3, 4. So the next item there is what? This guy. Okay, then I count again. 1, 2, 3, 4. I put this guy. Again, 1, 2, 3, 4. I put this guy. Again, 1, 2, 3, 4. Then I put this guy. So at the end of the day, I have my 5 individuals to represent the population. Because you remember that the sample size was what? 5. I hope that's clear. So I have my 5 individuals to represent the population. Okay. So that's what we mean by the systematic sampling. So what you do is you always have to calculate your K. The moment you get your K, then you select every Kth item. Another option is to select from 1 up to n. So it means that 1 up to n means from 1 up to 20, you can start from any point. So that means that you can randomly select a number from 1 up to 20. So, Vero, I want you to select a number 1 up to 20. Randomly select a number, and let's work with it.
Number 9.
Number 9. Then number 9. So randomly, let's assume this is what Vero chose. Number 9. So now we are moving steps. So 1, 2, 3, 4. So we are going to select this guy, the person on the 13th position. 1, 2, 3, 4. So we are selecting this guy. Okay. 1, 2, 3. Aye. We are at the end. So once that we are at the end, if you are not careful, you will find yourself you may end there. But what you have to do is, after you've gotten here, you will need to come and start again. So now you will select this guy. Okay? Then you come again. 1, 2, 3, 4. Then you select this guy. Okay? Then at the end of the day, you have your 5 individuals. But this is the reason why I do not advise my students to go from 1 up to n. Because the 1 up to n, if you are not careful, you may skip it, and then you may not get the needed sample size. Okay, but if you start from 1 up to k, you always be within the first person to the last person, be within the range of the population size. And that's the reason why I always want students to use 1 up to k, but not 1 up to n. Okay. Okay, so that's for your information. Any question? There's a hand up. Please, let me call them. Vero, please, you can call them. Vero, please do that for me.
Okay, sir, please, good morning. I think it's because of the network. There was this question I was going to ask, but it looks like before you ended your statement, you clarified it. You initially said the first item should always be 1 to k. But when you ask the first sample or the first elements that we are supposed to choose, Vero said 9, and then you went ahead and continued with it. Even when you said we are supposed to start from 1 to k, which was supposed to be from 1 to 5. I don't know if I'm making sense.
Probably the network was not consistent on your side. What we said is you can start from 1 up to k or 1 up to capital N, which is the population size. And then we said that we advise you that you always start from 1 up to k. So what Vero chose was to illustrate that it is possible to start from 1 up to n. That's the population size. And that's what I just explained. Okay.
Good morning, sir.
Good morning.
Please, sir, can you briefly go over the calculation again for me?
The calculation is the population size divided by the sample size. So it means that you always have to know your population size. Okay? and your sample size. So it means that if you don't have the population size, you can't apply this type of technique. So it's always the population size divided by the sample size. And this time around, the population was 20, and then the sample was 5. So you divide 20 by 5. That's it.
Mr. Emmanuel, please continue.
Okay. Good morning, sir. I wanted to know if the first element selected randomly is also part of the sample. Sorry.
Oh yeah. Always the starting point is part. So that's your starting point. So please, if you are done, you lower your hand. If you answer your question, then you lower your hand. When you are done, you just lower your hand. But if you don't have any question, tell me and let's continue.
Good morning.
Good morning.
Please, can there be a case whereby the population will be given but the sample will not be given, but we rather be having the case?
How? And dear sisters, I'm saying that you will need your population size and the sample size before you can get your K. And the sample size is what you are going to use for your research. So there's no way you can work without your sample size. Okay?
Okay.
I don't know, probably you are thinking about the change of subject thing that you learned some time ago. Nobody is going to give you change of subjects. I'm so much concerned about the concept. This is the concept. It's not about change of subject. So you always have to get your sample size, okay, before you can compute your A. Okay. Vero, do we have any?
Yes.
Okay, so we can continue.
We don't have.
Okay, thank you very much. So let's continue. So the next is what we call the multi-stage sampling. The multi-stage sampling. The multi-stage sampling is very, very simple. When you combine, let's say we combine 2 or let's say 1, 3 of these techniques. When you combine them, that's all. You use more than 1 or 2 of these techniques, then that means that you are doing what we call the multi-stage sampling. And so, for example, let's say Vero want to do a research in Ghana. And so what she will do is this time around, she will start with cluster sampling, where she will group the countries using the regions, and then she will just select, let's say, Ashanti region, and then she will come and say, oh, and now I'm going to apply my stratified sampling. So she will group the Ashanti region into, let's say, various ethnic groups, and then she said, okay, this time around, now I have my stratum. I'm now going to apply my sample random, and so you see that she has applied more than 1 of these techniques. And so what she's doing there is what we refer to as the multi-stage sampling technique. So this is very simple. When you apply more than 1 or 2 of these techniques, then you are applying what we call the multi-stage sampling technique. I hope that's clear. Guys, are you okay with this, Vero? Are you okay? So this is a sketch. So you can see that from the sketch, we are starting a cluster. Okay. Later on, we group them into stratum, and later on, we are selecting the items. Okay.
Okay.
I hope that's clear. So we are applying more than 1 of these techniques, and that is what we refer to as the multi-stage sampling technique. Okay. Oh, let's move to the next one. The next one is what we call the non-probability sampling technique. The non-probability sampling techniques is very simple. This the next 5 minutes I should finish because it's very simple, very, very simple. Very, very simple. So we already know that the non-probability sampling technique is biased. is always biased. That one is always biased. That means that the selection is not fair. Probably something influence how you do your selection. So let's start with convenience sampling. So for convenience sampling, so you sample how based on how they are available, how convenient it is. It is to you, the researcher, how convenient it is to the researcher or how available they are to you, the researcher. So for example, let's say I want to conduct a research for nurses in Ghana. Nurses in Ghana. So this time around, I say I'm going by convenience sampling. So because I'm going for convenience sampling, now I'm fortunate I'm teaching nursing students. So I will sample Vero, the others to represent the nurses in Ghana. So it's based on how available they are. Based on that, what I'm doing is what I refer to as convenience sampling. So you just sample based on how available, how convenient it is to you, the researcher. Okay. So it is very simple, very easy, and less costly in applying these convenience sampling techniques. You don't do rigorous things in here and there. So that is what we call the convenient sampling technique. Convenience sampling technique. So we sample based on how available they are, okay, or how convenient it is to you. Now the next is what we call the purposive sampling. Purposive sampling techniques. Purposive sampling techniques. So the purposive sampling technique, what you do it, you sample based on the purpose of your research. So based on the purpose of your research, you can then sample. So you see that the purpose of your research is influencing you how to sample. Okay, so another thing, let's say I want to sample, I want to do a research concerning pregnant nursing students in Garden City University, nursing pregnant students in Garden City University. That's for class A. So now you see that my selection is going to be based on the purpose. That means I'm now going to select only the nurses that are pregnant. Okay, but a big but. But they are all nurses. Why are you selecting only those that are pregnant? Because the purpose of my research is for pregnant women. And so it means that the purpose has now influenced how I do my selection, how I get my sample. And so if I go by that method or that procedure, that is what we refer to as the purposive sampling technique. Purposive sampling technique. And the next is what we call the quota sampling techniques. Quota. So for the quota sampling technique, the researcher is always influenced by certain characteristics in the population for his or her selection. For quota sampling technique, the researcher is always influenced by certain characteristics in the population for his or her sample. Okay, so again, in the same class, now I want to sample to represent nurses in Garden City University. And we can all testify that in your class, it is always I'm going to have more females in the class than the males. And so then the researcher is now going to go by quota sampling. And so because of quota sampling, the characteristics in the population here is the sex. Okay, is sex. So if that being the case, then the researcher can say that, oh, I'm going by quota sampling. And so if that's the case, I want the females to represent the sample with a high proportion. Let's say majority of the members in the sample should be females, and let's say minority should be what? Males. Or you can say that I want, let's say 90% of the sample should contain females, and let's say 10% should contain males. And so you see that here, he is being biased based on that characteristics in the population. So that characteristic is influencing him how he go on to do his or her selection. I hope that's clear. That's what we term as quota sampling technique. Quota. So you see that here, you, the researcher, you are saying that this characteristic is bringing its quota, this characteristic is bringing its quota. So you determine how they contribute to the sample. So each characteristic contribute its quota to the sample. And that's what we refer to as the quota sampling technique. And the last one is what we call the referrer or snowball sample. The referrer or snowball sample. Referrer or snowball sample. So for the referrer or snowball sample, what you do is you always and always and always and always and always and always use it for a population where you think that they are somehow known, or let's say it's difficult to even get them. In most cases, it is used for sensitive research. Something like if I want to do a research for HIV patient. Okay, if I want to conduct a research for HIV patients in Garden City University, it will be very tough for me to get its individuals. But if I'm able to get one person and I just tell the person that this is just for research, I try to convince this person, and the person says, okay, that's fine. And at the end of the day, I can even motivate this person. It is very likely that this person will refer me to another person. Okay, so the moment I'm done with her, he or she will just tell me that, oh, okay, there's another person in here. I can go to this person, and that person too will lead me to another person, so on and so forth, so on and so forth. So I get to the last person. And that is what we refer to as the referrer or snowball sample. And that is what you use for your contact tracing thing. When there was this COVID-19, remember that there was a lot of contact tracing. So you always identify that person, then ask the person, where did this person go? So you just go there, follow up, so on and so forth. And this is what they also use for the security sector when they are investigating a scenario, investigating a case. They always have to identify one suspect, and they move on and move on and move on until they get to the last person. So that's what we refer to as referrer or snowball sampling technique. But my dear sisters and brothers, keep in mind that for the purposive sampling, there are a lot of them. If you read, you can get more, but these are the common ones that we use. And as I keep telling my students that you can even come up with your own sampling techniques, but you need to justify it. When you come up with it, you have to test it and see if truly you can accept it or not. But I always tell them, I have not decided to come up with sampling techniques. Why do you? But it doesn't mean that you cannot come up with your own. Okay. Okay, so that is for the day. Any question? Any question? So this formula, my sisters, you can put this formula somewhere. I normally this are another method for computing sample size, but I'll talk about this next week. I'll talk about how to calculate the sample. But normally I don't teach this one. This I tell my students this is an old method. So okay, so any questions so far? I'm done. I'm sure you people are surprised. I'm done. I'm done for the day. I don't want to bombard you with the calculations for today. So God willing, next week, please, that one, get yourself calculated wherever you are. Then you practice, okay? Any question? Vero, please, can you? Or before Vero, you call them, please, do you have this slides? Do you have this slides?
Yes, please.
Okay, fine. Okay. So please ask questions for us. Call them.
Okay, sir. Miss Mary come. Please, you can say. Miss Mary, okay. Hello.
Call another person. She's not ready. Very call another person.
Okay. Manuela, okay, about it. Miss
Yeah,
Manuela.
please, can we go over the convenience sampling?
Oh, shit. Hello. Good morning,
Yeah.
sir.
Hello.
Please, I couldn't get the quota sampling very well. Hello. Hello, sir.
Yeah, one at a time. One at a time. So when we call you,
Please,
you
I
talk.
said, can you go over the convenience sampling?
Oh.
Okay, so mute your mic.
Hello, sir.
So,
No.
okay, Mary, you can now talk. Mary.
Mary Okran. Please, I said I couldn't get. I would like, sir, to go over it again.
Okay. So for the convenience sampling, the convenience sampling, you sample based on the convenience sampling. You sample based on the. And please give me some feedback.
Hello, please don't think that you can't consider the license of the please it's already in the book.
Yeah. So for the convenience sampling, you sample based on how available they are to you. Okay, how available they are. So you will sample based on how available they are. So, and at your own convenience. Do you get it? So that one is depends on you, the researcher, at your own convenience and how available they are. And the quota
Okay.
sampling, you sample. Yes, yes.
Please, with the slides you are teaching today, we don't have it.
Are you sure? Okay, don't worry. Please, immediately after the class, send me. Okay, you send me hi right now. I'll forward the slides, the video. As for the video, you have it already, right?
For
Yeah.
next week's calculation, we have it, but for the one you are teaching today, we don't.
Oh, that's good.
Yes,
Okay,
please.
you send me hi. I'll send it to you.
Okay, sir.
Send me hi right now. I'll send it to you.
Please, what video are you talking about? We don't have
Okay,
the
so
video.
please, you have the video. Please, you have it. Don't you have it. Don't complicate things. You have it. Go and sit
Yeah.
and then read the you have it. That one I'm certain you have it. Okay, so now let me answer that of the quota. So for the quota sampling, the researcher will always select based on certain characteristics of the population. And so that's why I cited that, for example, your class, let's say we have a lot of females. So the researcher is going to select based on that characteristic. Based on that characteristic, because there are a lot of females, he or she is going to say that, oh, probably this time around, I'm going to select more females than the males. And then you see that the characteristic has influenced how he or she selected the individual to be part of the sample. That's what we mean by the quota sampling. Okay, so Vero, I'm done. Then I think I've answered them correctly. So you can call the next person.
Okay, sir. Please, there is no one else.
So we are done, right? Okay,
Yes, sir.
so if there's no question, then let's meet God willing next week. We have about 15 minutes to relax for the next class. So please, oh, I think there are some two hands here, or have they all talk already? Emmanuel Sabwaji, you have a question?
Okay.
Emmanuel Sabwaji, do you have a question?
Yes, please. So for the culture sampling, let's say the girls are equal to the boys in the class. For that one, can that one to be a quota sampling?
Why not? It can be a quota sample. So this is, as I said, all these things, it depends on you, the researcher. So you, the researcher, you have to identify what characteristic that you are going to use to, do your sampling. Okay?
Okay, and then for the
So it depends on you,
convenience.
the researcher.
Okay, thank you. For the convenience, let's say where I stay right now, my church is very convenient to me. So I can use that place as my research.
Yeah, if let's say you want to get information from church, so you can use your church. That's it. So you just do these things based on your convenience. But you need to justify all these things.
Okay, thank you.
Okay. Please, you lower your hand when you are done with you. So the next person is what?
Mr.
Hello, sir. Mine actually isn't a question. I just wanted to see the opportunity to make an announcement to the whole class. So,
Okay,
I
so when
think,
I'm done, so when
yes,
I'm
yes,
done,
please.
okay, so when I'm done, you can make the announcements. Do you want me to go before you make it?
Oh,
Whilst
sir,
I'm here.
in your presence, I have no problem to around. It's
No.
for the. Sir, please, good morning, class. To the whole class, I believe we've all seen the assignments with respect to the group discussions we are supposed to do on theoretical lessons. So I believe so many of us may think that we are doing the submissions on the presentations that were given to us earlier. But from our lecture on theoretical lesson, it is not that particular presentation they would want us to be presenting. It's a different assignment altogether. That is has also been uploaded on a G class. So let us be mindful of that. But to the group leaders, we are not being asked to do the presentations on the 26 different theorists we were asked to present on. This is different. So let us all go back to the V class. Look at the theorists we are supposed to present on, and then do our group assignments. So from the information I received from the lecturer, similarly, we are supposed to come up with a presentation in 12 slides, just as we were given earlier on the theorists that has been assigned to your slides are supposed to similarly. Hello.
Talk. They are hearing. Talk.
Yes. What I was saying was that the 12 slides.
Can I please I think I can leave then you discuss this, right?
Okay, sir. Thank you.
Okay, so my sisters and brothers, I'm leaving. So God willing, we meet next week, okay? So God be with us all, then we shall meet next week. Vero, just send me hi and then I'll forward the documents to you guys.
Okay, sir.
Okay, bye.
Bye. Then.
All right, so just as I was saying earlier, the presentations we are supposed to